Hey, we are finally getting to some fun stuff now. So, after 12 lessons of just getting the foundations, lesson 13, we finally get to a little bit of movement with our sprites where we truly get the animation aspect, more so than just the shaking we saw in lesson 12, to our code.org. Unit 3, Computer Science Discovery, Animation and Games. Unit Lesson 13, surprise, surprise, starts with a prediction. This pattern is one of the most important ones in all of programming. It is called the counter pattern. It simply just updates a value each time something happens. So we create a variable called counter, set it equal to 0, and then inside our draw loop, we have a white background. We have a text size specified, but it is the value of the number stored in the variable counter. We also have text to show up. However, we are using no quotation marks. We just have counter. What that means is what is going to be displayed as text will be the value stored in the variable counter. It is being listed at 0400. So that is going to be the XY location. And then we can see the update. So every frame, every time this loops around, what this means is the value in counter will get the current value plus 1. So the first time it runs, initially 0, and then 0 plus 1 is 1. It runs again, 2, runs again, 3, and so on. So each frame it increases by 1. So when we click run, we can see at 0400 where it starts, and then it is going to grow, and it'll eventually get so big that we really won't even be able to see the numbers anymore. But you can tell how quickly the frames change, and it would keep going indefinitely. It will probably eventually break in code.org, but very simple program. Okay. And I will make an attempt to start over in these so I don't rush through it. So right now we have two sprites that are created. We have a jet and a plane. Each has an animation that is set to it, and that is done outside of the draw loop. Then we get to our draw loop. We have our sky blue background, and this is making the jet go up. So this is where we really start to see that aspect I've mentioned before, that with our y coordinates, as we go up, our y value decreases. As we go down, our y value increases. So if we want this jet to appear to rise up, we are doing a counter pattern with its y position. And this is early on. We'll eventually learn about velocity, but for right now, this is all you need to know. This is kind of giving the illusion of speed. So the degree of change right now, 3, that is 3 pixels per frame, is also kind of factors into how quickly it moves up. So if I were to change that to like 10 and reset and run, it's going to move a lot faster. If I change it to a 1, it will obviously move a lot slower. It's just going to be moving 1 pixel per frame. But nonetheless, still that constant movement. I'll put it back at 3. All right, so to get the plane to go across, we want it to move from left to right, which means if I drag across and I look at that X value under the run button, it's increasing. So I want to mimic this, except I'm going to do it with the plane's X property. So I'll go to my sprite menu, and I'm going to drag out a sprite dot, not a dot y, dot x. Okay, and the name of the sprite or the placeholder that I want to move is the plane, and it's going to get plane dot x plus 3. So y is going to move up and down, x will move left to right. Now I run it, and my plane goes across the screen. At level 3, this one, already have the code there. So if we want it to go the other way, we have a fly. Again, we create the sprite or the placeholder. We set the image of fly to the fly sprite. We draw our background inside the loop, and then we update the X property. This time, because we want it to move from right to left, we do a negative counter pattern. So the fly's X position, each frame is going to get whatever the previous value was, minus 2. And then, of course, we draw, and we get that illusion of the fly moving across the screen. All right, level 4. This one introduces the concept of a watcher, which is something down here in our debug console in our tool area. I'll start over on this one so that I don't lose anybody. All right, so we have a mouse.x and a mouse.y. Once we run the program, it gets a value. Notice the mouse.x stays constant at 50. The mouse's Y position is updated every frame. So this little watcher tool is a cool way to, sometimes if you're testing out some code and you don't want to do stuff with the user interface, right now obviously it's clearly the interface, we could look at it and tell, but this allows you to track the value stored in variables and allows you to get output at different times. So very useful tool there to have at our disposal. So we want this to move diagonally. Right now it is moving down, but we want it to move to the right. So not only do we want it to move down, but we want to move to the right. So we're going to update its x property. So we'll do mouse.x is going to get mouse.x plus, and I'm going to use the same rate of change so that it is more, does move in a true diagonal way. So it will, the slope would be 1 for those math folks out there, and that will go kind of perfectly diagonal. Every frame, its y goes down 2, its x goes over 1, and it moves diagonally across the frame. Or across the screen, I think I just said frame. All right, level 5. This program will predict which of the following animations will be produced, and it wants us to guess. Looking at the code, okay, I'm not going to show you the answer. We have a red car, a yellow car, a blue car, and a green car. So just looking at it, the red car is going to move left to right. The yellow car is going to move top to bottom. The blue car is going to move right to left, and our green car is going to move bottom to top. So whichever of those options that would be, you could click and guess, that would be C. Okay, some challenges. All right, I think I did all of these, so we'll again just kind of share the code and I'll talk about it as you look. This one's very simple. It is just a counter pattern with the rotation. So every frame, the rotation is going to update by taking the previous rotation plus 1, and that gives us the illusion of spinning in a clockwise pattern. If we wanted to spin in the other direction, we would just use a negative counter pattern and do pan.rotation gets pan.rotation minus 1, and it would spin the opposite way. Again, we create the sprite, set the animation above the draw loop, set the background inside, have our animation, and then draw sprites. All right, another one with the counter pattern. Initially with this one, it's moving in the wrong direction. To fix that, you want to make sure you want this one to move up and to the right. So your x needs to get an x value plus your y because it's moving up. All right, as we move up, our y decreases, so the y needs to get a y minus 10. We are using the same rate of change. It's just the plus and minus really are directional. So make sure we have that. Then we draw sprites, and our little motorcycle goes from bottom left to top right. Okay, this last one, I don't know why. This one is just always very enjoyable for me, just the way the images kind of fit together nicely. It is all digital. It is all kind of, for lack of a better term, fake, but it just looks cool. So what we have are 3 different gears that are drawn in various locations on the screen, and it appears they all fit together perfectly. So we create the placeholder, set the image. Inside, we have a background that is white, and then to make the gears rotate so they look like they're working as one system, we want 2 of the gears, so the first and the last gear, the red and the green, notice if you watch the image, we want them to spin the same way. We want them spinning clockwise. However, to give the illusion of the gears working together, we want our blue gear to spin counterclockwise, so it's like getting spun by red and then in turn spinning green. So if you notice with our counter pattern, the red gear and the green gear are both getting the previous rotation plus 3, but the blue gear, which is that middle one, is getting a minus 3. Again, the plus and the minus dictate the direction. This kind of the absolute value here dictates the speed. So they all appear to be spinning at the same rate, but this plus with the red and green make it spin clockwise. The minus with the blue gear makes it spin counterclockwise, and we have this nice, cool little animation. You could change it. The higher the number, the further the number is from 0, absolute value, the faster it's going to spin. The closer you get to 0, absolute value, the slower it's going to spin. Alrighty, so that finishes the practice problems. All right, let's go look at our assessment. And for these, I may have some extra stuff. I can't remember. This one seems like it builds, and if I start over, it's going to get me elsewhere. But again, we're using that counter pattern. We have 3 sprites. We can look at the preview. Here we've got a dark blue background, and then 3 sprites swimming across at various speeds. So blue's fastest, orange second fastest, green slowest. So we create the sprite for each fish, and then we set the animation for each. Notice each time they're getting different Y values, so each time we reset and run, our fish may be at slightly different heights. All right, then we draw our navy background, which is the deep blue sea, and then we update the variable. So the orange fish is swimming from right to left at a rate of 2 pixels per second, or per frame, I should say. The blue fish is moving at 3 per frame, and the orange or green fish is 1. So this would be the fastest, second fastest, slowest. Okay, that number, again, absolute value indicates which one. So I did not insert that with the comments. I just kind of put it there to update the values. But that is how it works. We draw animations, and it gives the illusion of every frame. That X position being changed slightly gives the illusion of the fish swimming across the screen. Okay, so all of these nice little challenges, we have all sorts of stuff we can do with more fish, more sea creatures. For my students, I'll go in and show the wiggle, and then also show how to do the bubbles. Anything else, like adding a shark going across, I think you could probably pick up. You would just need to create the shark sprite, set the animation, make it move from left to right. Not that difficult. Adding other things, again, you're updating the Y properties. So let's go in and look at more fish. Let's make them wiggle. Let's see if I have that in there. Okay, so this is one I have later. So this one is used later, so I think we want it to do it regularly. So I am going to have to change something here. So I'm going to move these. Later on, we'll get to controls, and that's why that's... Okay, so to make the fish appear to be wobbling, I just have a little rotation that goes from -5 to 5 to give them a little wobble to make it look like they're swimming. And then to add bubbles, what I'm actually going to do is draw some circles, and I'm going to do that after my background. So I'm going to set a few things up, though. I want to set a stroke color that is white, and then I want a no fill, okay? And that will give me kind of an empty circle, and then I am going to create a few different ellipses. The first one, I'm going to set an X value of, let's just say 50, a Y value of 400, and then I'm going to do, let's do maybe a 25 for the size. All right, I'm going to update that and do a couple more, but I'm going to change these values. So I'm going to do 425, 450. And what I'm going to do as well, I'll eventually go in. This one needs to be about 150. I'll make that one at 300. I want this to be able to change. That's where I want it to be initially. So the first time I draw it, I'm actually going to draw them outside. Let me think of the best way to do this. Oh, I did not mean to go to my cluttered desktop. Pardon me. I'm going to create a variable up top. I'm just going to call it bubble y, and I'm going to set it equal to 0. And what I'm going to do right here is I'm going to do that initial value, but I'm going to do, because as we go up, it decreases, so I'm going to do 400 minus bubble y, and each one I will do minus bubble y. Oh, I did it equals, not a minus. Okay. Okay, and then after I draw it, I will down towards the bottom update bubble y with a counter pattern. I'm going to use the x equals. I'll do that after the draw sprite. Bubble y is going to get bubble y plus, I'm going to give it about a 3. So as that number increases, the amount it's subtracting would increase, and I have those bubbles that are now going up, and I'm altering the y coordinate of the bubble with a variable. So you can add animation to shapes that you draw. It's just a little trickier. We don't have that nice and neat, sprite.x, sprite.y. We have to give the x, y a variable and then update it. But because I wanted them to start at certain points, I was able to do that and then just subtract the value of bubble y and make bubble y increase and go up. If I want the bubbles to move more slowly, I can change that to a 2. All right, and then we see them going up. Okay. So again, to add a shark, hopefully by now you know how to do that. You would just create a sprite, set the animation, position it down towards the bottom, have it move from left to right. You would need a positive X counter pattern. If you have questions on that, reach out, let me know. Otherwise, I will conclude the lesson 13 video.